Hello everyone and welcome back. In this video we're gonna talk about bank switching, so stick around for that. Alright, our last video. Like I said in the previous video, the next video we're gonna go over I'm gonna create some games with everything we know so far, but let's just stick to the subject and tell that towards the end of the video. So we're talking about bank switching, and before I get to that, let's look right over here at my picture that I took. And that is my game, Prologue. Here's my cartridge. I opened it up because the game wasn't working, so I just opened it up when I got it to clean it up and see if there's traces were working, and they were working. I think our ROM over here is already gone, so nothing much we can do about that. But the only reason I took this picture is only to show you guys that this small place that we have over here, the metal that conduct our electricity. This was the PC board over here, our circuit board over here, and we insert this cartridge right over here, and when we insert this into the Atari 2600, it reads the program right over here. So this metal's it's conducting electricity, so it's reading all this information over here. So if you remember, the Atari 2600 had a little bit of limitations. First, with RAM, or random access memory, we only had 128-bit, and we have our 4K of bytes for our ROM over here. So there was a little bit of limitations, but if you remember what I said on the video on collisions, with limitations people get creative to come to solutions for those problems. And one of the solutions to RAM was to have an extra RAM right inside the chip, because it doesn't really matter, because all this is doing is reading electricity descending from ROM over here. So if you have this extra chip over here with a RAM over here, and you were to write over here like, hey, and this, if I write to this address, it actually means not the Atari place, but our RAM over here. So that's what they came around. So one of the solutions was to add more stuff to the chip, and that's what happens. Default 2, if I believe I'm right, had the extra chip for sound effects, and other chips have different other chips for doing different type of having different types of solving different type of problems. So the Default had the sound, the super chip that has extra RAM, like games like Dig Dug had that. And another issue was, like I said, our size of games, 4K of bytes, because really gaming was in its infancy back then. Even though there's you could say the Magnavox Odyssey and other games and so forth were around, but it was at its infancy. So when they made the game Combat and all those launching games, people thought like, oh, okay, that's gonna be good enough. But it wasn't. Even up to today, we always trying to do better. So one problem they're getting over is like, how can I want to make better games? We're gonna put more stuff in games, so we're gonna need more ROMs, more bigger ROM space, and that's how they came out with bank switching. So I only showed this picture just to show you guys that this is only sending electricity or ROM or image. So as long as you put something on the cartridge itself, it doesn't really matter. So let me switch to the page which we're going to cover bank switching. Alright, bank switching time. And here's our material, Atari 2600 Bank Switching Methods by Kevin Horton. So let's go over what a bank switch is. Here's the different methods and so forth, but let me go down here. And bank switching just allows to include more data into the cartridge. So circumvent the 4K limitations to have more memory. That's pretty much what I said before. And bank switching, like I said, works similar to all cases, but what it's doing is just reading a certain location on ROM switch banks. There are two different forms of bank switch, and here we have our 4K blocks. Here we have F6, but let me just draw it out. So imagine if I have a CD, if you will, and if you know about CD, they have different sections. So let's separate this into like a 4 section. Oops, something like that. and each of this section is a 4K. So if you think this as our game right over here, it's kind of awful, so just think of this as our main part of the game. So have some data over here, and at a certain point you're running your code and you want to jump right to this side on this section. There's more data over here, so you're going to do some data over here, and then you're going to return to your main part right over here. So as you see, we're switching sections. There are more sections we can do. There's more banks and so forth. So that's pretty much what a bank switch is. So let me just draw this in a cartridge. So here's our cartridge. Here's our special cartridge and so forth. Here's our ROM or EEPROM. And here you can either have like 2 4K bits or so forth. You can have 2 or 1.8, doesn't really matter. What matters is that we have at least more than 1 4K ROM-PROM over here. So you can have 1.8 or 2 4s or whatever. And each of them is one bank. So there's information over here. Then you can come over here, get back and forth. So you're switching between banks. And that's what bank switch pretty much means. So let me clear this out. Okay. So let's go over here. And here's the different bank switches. We have no bank switching. We have F6, F8, which is the earliest one. So, and each one of them has different people. Like Activision has this one and so forth. And here he has a list of a bunch of games and other which kind of bank switching and so forth. But let's just go back how it works. So here is an example. So let's go over here. We have an F8 method. An F8, where is this? 2 hotspots. And hotspot is pretty much how we switch banks. We don't want to write to them, so no store. Might conflict some bugs, some bus issues. But what we want to do is just like read it, so you can like do some load, compare, and so forth. So in the example, it has load. So never do the stores. Never write to it. So we just want to read. So let's go over. So what happens is we start at this bank over here, bank 1, and from here we call the subroutine. So come right over here, and here it says load 1FF8. So switch to bank 2. So this is our hotspot right here. And we do this, we change to bank 2. So that's what it happens. And then remember, checks the bank, we basically run swap. So okay, so now we're bank 2, and the processor sees that there's a. Okay, so let me go over. So we have the address 100, and we had the load in this value. So there is a 1, 2, 3. If you think about it, so there is a load. Our opcode over here, and there's 2 values for our location. So now we at location 103. So it's right over here. So that's what happens. So we're not over here in 103. We are on this one because you did a bank switch right over here. And here it says jump to subroutine 1000 right over here. The subroutine goes here. Now where am I over here? Now in bank 2. Which is the subroutine, whatever is executed. Now we execute the subroutine and exit with a return to subroutine. So we're returning from the subroutine, and I believe, where is it? Exit to 106. So return from subroutine. Which one's the last one? Subroutine. So right over here. So when we do a jump to subroutine, it's gonna push this value to the stack. So we're gonna return here. So it's gonna go back over here, and so far. So we do subroutine, return it. Now we're right over here. So return it. So it's after this level over here. So there's something going on over here, and then you do a bank switch again. So this is 1FF7. So it's not really F8, we're F6. This is F6. And then we're back at right here at this bank because this is a special hotspot over here. And we are at 6, 7, 8, 9. So right here, return, and we're done with the subroutine. So that's pretty much what happens. So we're gonna different 4K memory banks, and when you write into those banks over here, when you not write, my apologies. When you read to those memory banks over here, well, you can write, but you shouldn't do that. Then you're gonna switch to this side of the ROM, so back and forth. So that's pretty much a bank switch is. We're just switching our ROM places. And right over here we have the different methods. F8 is one FF8, one FF9, and so forth. And here is all the wonderful stuff that we have. So this pretty much covered most of it. But if you come here for the 8-bit shop, let's go to their EDI. And here it is, the bank switch method. And it's the exact same thing. If I were to press our action button over here, where is it? Here it is, bit input to 4. There we got this rainbow color. And here he has something called the trampoline, which is something that we can demonstrate. Here it is demonstrating the trampolines, some safer way to jump between banks. Here it has a trampoline. And let me just cover this really fast. Okay. So actually, let's just cover this and then I'll go back to your Eclipse. So, okay, so here is our average code as always, and here's a macro. And why is a macro? Because in these two banks he's gonna put all this thing. So instead of copying and pasting everything all over the place, just use the macros over here. And then he's gonna just copy this and be over here, copy this. So in bank 1 and 2 is the same thing. So let's go over this. This is the switch trampoline. So we're gonna push A into the stack, they're higher by, then we're gonna transfer Y to A, and then we're gonna push again the low by to the stack. And here we're gonna load, we're not gonna, or F8 or F1. I mean, this is an F8 method. So if it's 0, it's gonna be F8. That's for X, right over here. So X is the bank number. So if 0, it's F8. If it's 1, it's F1. So A has the high byte and Y has the low byte. And then we're gonna return to the subroutine. And with this return, I was gonna do, since we store this memory location, we push into the stack. Return is gonna go to this location right over here. Here we have our bank switch, a macro. So we're gonna load the high and this is the high and low bytes. And here we're gonna do the bank switch. So it's pretty much, and then I'm gonna jump to bank switch, and bank switch is right over here. So it's gonna jump to this part of the code. Here we have a bank prologue, and this is to make sure we always at this right bank site, because depending, we don't know, the Atari can either gonna be on this banks or on this bank. So to do that, he has a bank prologue which load the reset, which is right here, reset 0, for the bank, whatever, and just make sure it's right over here. So this is the address. Here we have -1 simply because we want to decrement the address by 1 because the counter is up by 1, so just even it out. And here we make sure the load X, transfer X to the stacks, then increment it to be equal 0. So just making sure that it is the start reset right over here. And here's our bank factors. This is our interrupts that we always have. So make sure you put them right over here. And like I said, all this do is just copy this code and paste right over here. So here it is. So fourth clean start. And if you press 0, if you press action button, the wrap button on your input. If it's not pressed, repeat. Otherwise, go to bank 2. So nothing is happening. Let me press. Oh, not you. Jesus Christ. Go back. Okay. Click over here. So this is what happens. So if you press, let's do a. If it's not pressed, just reset. So it keeps doing this forever. Otherwise, I mean not forever, but let's see. Bench reset. Just keep doing this. So it's right. And otherwise, just do this. Let's go to the main one. The main one is right over here. So if I just doing this. So Jesus Christ. Okay, press over here. So loading the high and low by of main one -1. We are loading X21 into bank switch and go right over here to bank switch. Well, it's gonna go right over here to this one, of course. But when it goes over here, we're gonna go over our bank macro. So it's gonna push A. So this is gonna be Q1. So you gonna be F9 and then go back to bank switch 2 right over here. So now we're over here. Main, so increment temperature, so our temp value over here and so forth. We're just creating a rainbow effect and so forth. So just a test button, otherwise go to bank, otherwise just reset. Go to reset 0, you let it to 0, so just switch it over. So that's pretty much what this trampoline does. It's pretty easy. And in order to have when you're using DASM, in order to let us know that we're using bank switching, first you have our origin right here, 1000, and our relocate origin right over here is going to be different over here. So this is our page 200, but relocate origin to 1000. So that's where it actually is on our ROM side, on our ROM, and this is where the code or the Atari thinks where it is. So both of them are 1000. The Atari thinks they're 1000, but they're different sections of the place. So just put org over here to our physical location. So there are 2 different banks, and we relocate org where the Atari think the code is. So just because right over here. So both of them thinks right over here. So here the same address. Both of them think the Atari thinks doesn't really know. He only knows that's the actual address. So here in this is exactly the same. But the relocate org tell us, even though the relocate org tell us this is the same, it's different size of the round place. So that's pretty much how the bank switching works. And if I were to, let me just copy and paste over here on the sample, and let me assemble and run it. So here it is. Hopefully you can hear my space bar. Same, it works. Let's go to debug just to show you something really cool. And right over here, you see cartridge F8. So right over here, the different banks and so forth. So the Stella emulator actually knows, if you come right over here, that we're in different banks, and there's different banks over here. Here's bank 1. So the Stella menu. So let me go over here. And let's look at some games over here. Combat. This is the first. If I'm correct, here's Chuck. This is a 2K game. It's non-bank switch, so he tells us that. And I believe this was a launch game. So as you see, games at the time was really limited by this amount. But of course, later on, let's see Frostbite. Let's see what the cartridge run is. It's a 4K game. Still not bank switch. Let's see. Hero. And here it is, an F8 cartridge. It says right over here. And here it is, the hotspots, F8 for bank 0 and F9 for bank 1. So as you see, there's a bunch of games over here that use a different bank switch. And let's just look to Solaris, which was one of the latest one of the last games of the Atari 2600 that took it to the limit. As you see over here, one of the crown jewels of the system. And here it is in F6 methods, and here's different bank switches. So that's pretty much it for this video. And we went over the bank switch. Let me see if we can return over here and save the sample. Alright, so that's pretty much it. We cover a lot, and we're gonna use everything that we know that we went through so far, from the all the way back to the 6502 instructions. Then we went over the Desmond, then how to program to the Atari, and now we're gonna create some games. I'm not really sure what kind of games, but we're gonna catch it. And with all that said, that's pretty much it. See you guys in the next series. So thanks, and thanks for watching. See ya.